Hello children, hello everyone. In this class, we are going to understand the important topic that is domestic electricity. See what is this domestic electricity means in your household appliances like electric fan, geysers, mixers, grinder or bulbs, everything will work. So when we will pass electricity to them, so where we will get this actually electricity? From this wires, it will come to our wires. From this wire, where you will get electricity, okay? That is from hydroelectric power stations, okay? Nowadays nuclear power stations are happening and windmills, so many sources are there for electricity. When it will come from that sources to these mains, and this mains to submains and submains to your homes, it will come. Once it will reach our home, okay, it will suppose this is your okay, at the starting of your houses, you can observe one kind of rectangular box, that is a meter box. Okay, what we will call main junction box. From where to inside the electricity will go. So that is what we are going to learn today. That is not from hydro and down. We are going to learn from this main to inside supply how it will be, electricity will be. So which wires, meaning which, okay. Suppose you can observe no different colors of the wire, red color, black color, and green color wires. So each color having specific meaning there, and in your houses you can able to see some plugs will be very small plugs. This rated 15 amperes, very small plugs, only 2 pins containing, 3 pins containing. Sockets also you're going to observe, right? So for mixers, grinders, okay, very high power supply, they will have some red buttons which having high power supply or very low supply. So all the questions of this kind of thing, what is there in your household domestic electricity, in this we're going to understand, children. Clear? Please stay at the end of this video. You will definitely understand how electricity in your home it will be workful. Okay, whenever the fuse how we need to work, okay, everything we're going to understand. Please stay up to end of this video. Okay, please don't go out. Okay, let us come back to the topic, that is domestic electric power supply. Okay, domestic electric circuit, it will contains, look how it will look in your homes means the first electric power generated by electrical power stations. Okay, it will be going to generate there. After they are generating electric current from there, they supply electricity to our homes through what? Through electrical poles. I think you have seen that one in the last video slide. That is coming through our homes by electrical poles or underground cables. Sometimes we can see the underground cables also, and sometimes you can see, okay, one just a minute, I'll show the picture. You can see here the green wire from underground that it is coming, and sometimes from up you can see the wires from mains also it will be coming. From power stations to our home, electricity will come like this. Okay, two ways. One is underground cable and another one is electrical poles. Electrical wires. Okay, what you are going to take now? Electrical wires. Yes, children. There are two types of wires we're going to observe. One is live wire and the neutral wire. Okay, two wires. One is live wire. From this electricity will come, and the neutral wire from the electricity will go back. See the red color insulation. Suppose in your house you can observe the red color insulation of the wires will having red color insulation outside, and one more color, the black color insulation you can observe. So the red color insulation means that it is a red wire or a positive. Okay, live wire or positive wire, we can call it as a live wire. Okay, remember children, and if you any parents, you will tell them, okay, so this red color I know that is a live wire or it is a positive charge, it will be flowing inside them. And if it is, if the black color insulation is there, that is a neutral wire. Okay, or we call it as a negative wire. Clear children? Two wires will be in your home. You can observe if you want. One is the red color wire and a black color wire. Red indicates a live wire and black indicates the neutral wire. Our neutral wire is called negative and live wire we call it as a positive. I hope this is clear, children. Yes. Yes, yes. Yes. You can observe in your homes, wherever you are using electrical power supply, the sockets will be there. No? From there you are using the electrical power supply. That means, see how you are comfortably using the electrical power supply in your home. The two types of plugs or sockets we're going to use, I'll explain that. First you will see these wires. Okay, these wires are passed into electric meters through the main fuses or the MCBs. First you can observe here electrical live wire is there. Okay, neutral wire. You can observe no live wires of the red color and a neutral wire black color. Once they will come to your home, it will first enter to an electricity board. What you call electricity board. Inside it, you can observe here no fuse will be there. Okay, what is the use of fuse? How it will work? I'll explain again. Okay, electrical fuse it will enter. After the fuse, no, it will passes to electricity meter. From this meter board only, the electrician will give you a bill. Okay, 350 rupees, 450 rupees. You burn 5 units of current, 6 units of current. You know, 1 unit means 1 kilowatt hour. This is the power what we are consuming actually. How many kilowatt hours? Number of kilowatt hour gives you the electricity bill. Okay, that is what given by the electricity meter board. From the meter board reading, they're going to give this. And next, it is connected to distribution box containing the main switches and the fuses for each circuit. You can observe in your home, so you can open this distribution box and you can switch off and on. Okay, distribution box it will contain. After from the distribution box, each circuit will have again one separate fuses. Okay, in the distribution box, again it will go into the main supply, the sockets. Okay, see in the sockets you can observe, I think in the rectangular sockets in your home, one is some bigger knot and either with a small 2 knots like this. Or even though some big sockets you can observe, it will contain 6 also. Okay, bigger one, 2 smaller one, still 2 like this. Okay, that like the sockets you can observe. If you want to connect smaller, you can use this. You want to connect bigger things, you can use like this sockets also. Okay, so all these kinds of sockets you're going to observe in your home. No? So what is in this screen? Here you can observe the one is for live wire, one node is there for live wire and other is for neutral wire, and one more you can observe. What is the use of the third one? One is live, one is what is this? Yeah, neutral wire. So live wire, what is the work? Is that current will be coming from this live wire. What is the neutral wire? Again, it will going back current. That means complete circuit will done. But what is the use of this other one more node? Okay, that means third one that is connected to the earth. Okay, that is what we call earth wire. Usually it is a green in color. It will be connected to the earth. Okay, you can observe all the plugs here. How many plugs we want in your house? We are going to take it in your case of series. I explained in case of series and parallel circuits, we always connect in household for parallel purpose only. We not connect series. Suppose instead of this parallel, we will going to take in case of series. Suppose you taken one appliances in series like this. What will happen if any one appliances stop working? Okay, imagine in your kitchen, if any one appliances stop working, so what happen? All appliances will not work, because if one appliance is not working, in the sense it will make a open circuit. If open circuit means current will come in here, how it will go to second appliance? So that it will stop, so it is not working. That is why we cannot use the series circuit. Okay, we cannot use series circuit in a household purposes. We always use parallel circuit only. Okay, inside our home, the circuit will be what, children? Parallel. Okay, if anybody asks you, remember it is a parallel circuit. Okay, understood. Live wire, red color, neutral wire, black color. The live wire, okay, is, you know, that will be, sorry, green color wire, you can see, that will be connected to earth. If any extra current or leakage current, okay, happen, that will be passes to the earth, because earth have a potential of 0 volt. Okay, it will be maintaining potential how much? 0. Because of this 0, whatever the potential will come, it will try to accept it. Right, children? If nothing empty, just 0 potential means no charges in it. Imagine null charges. So that any charges will come, just it will going to accept it. That is why we call 0 potential as the earth. So whatever the current will come, it will going to accept it. I hope this is clear, children. Domestic electric circuit in your home, how it will be live wire, neutral wire, electricity board. It first passes to electricity board, again from the board to meter, electric meter to distribution box, and a distribution box to parallel circuit. Okay, this is how the circuit look like. Right, live wire, neutral wire, and from sockets to we going to connect the earth wire to the ground. Okay, how this earthing we going to do, I'll explain you. Yeah. Yes, children. You can observe here. Okay, what you're going to observe here, 1 second. Yeah. See, I told you in the ray diagram wise. So now you can observe clearly how it is red wire. You can see, no, this is your electric board. In the electric board, you can observe no 3 wires. One is this is a live wire. red color wire, no, live wire, or we can call positive wire, and the black color wire you can observe here, no, this is black color wire is a neutral wire. This is a neutral wire, and this is called as a negative wire, and the blue color wire is, this is what we connected to the ground. Okay, sometimes we can use blue or green also we're going to use for the neutral wire. This is connected to the earth. You can see all the way. Okay, the three will be there: live, neutral, and the earthing wire. So like this, our circuit will going to look like actually. Clear, children? This is okay. You can see, observe here, normally two circuits are used in our household. One is 50 amperes current rating circuits, and we can use 5 amperes current rating. This is 50 ampere rating means if you want to use the geysers, okay, geysers or any grinders in your home, they will require what, children? More electric current. Okay, they require more electric current to operate. That time we're going to use the 15 ampere circuits for electric iron and geysers kind of thing. And if very low, suppose mobile charging and all, charges and all, okay, the tube lights and TV, they will require very less power. Okay, they less consume power or less current they will require. For that and all, we are going to connect for very low rating, 5 amp rating. This is what we call 5A and 15A plugs we can see. Okay, this is a different two types we can normally use in our houses, right, children? Different sockets in a switch. That there are normally 3 sockets in a switch. Okay, 3 sockets we can observe in a switch. Switches. These are live wire, neutral wire, and earth wire. See, live wire it will be in the red color, neutral wire will be black color, and the earth wire will be in the green color. I showed actually in the figure also. I think no doubt it is. Now you can observe the 15 amp how it is look like. You can observe now this here 5 amp and the 15 amp. The 5 amp you can see they're very small. You can connect to the plug box like this. Okay, the 15 amps you can see, you know, the gap between is also more. Okay, if there is required specially the different plugs for this. Okay, big plugs are required for this. So to operate the okay, like AC, air coolers, or to operate the refrigerators, we're going to use 15 amps. Okay, plugs. If you want to operate very low, like a washing fan, or you want to operate a bulb, that time you go for, clear, children? You just imagine like a line. Okay, you want to operate ACs, okay, air coolers, and you want to operate refrigerators, you will go for 15 amp. You want to operate very less, 5 amperes, like a bulb and a fan, you're going to go up for 5 amp. Clear? These are the different types of sockets we use in your household. You can observe this and that. Okay. Now, if we are using that appliances, see, because their body is made up of what, children? Metal, right? The body is metal. Here also metal. Here also, like toasters also metal. You can washing machines, you can observe the outer body is metal, and some kind of iron boxes also plastic, and sometimes you can observe the base will be again made up of iron. So in all the condition, what happened, because of the carrying the metal base, if any leakage current is there, okay, if any leakage current will come from the circuit, that will pass us to where that the charges will be segregated on the top surface of the metal, because metal is a conductor, right? If you touch the conductor, that will, suppose you want to open the door, when that definitely you need to touch here. So when you're going to touch, if the charges are accumulating, leakage current will become, it will be stored on the any metal body. What will happen? You will get the shock, right, children? To okay, you will get what shock? Suppose this is a metal body. If any leakage current, what happen? It will going to store on this body. So when you get touch, you will get the shock. So for to avoid this metal bodies, you not get the shock. So what you need to do is that you need to connect this charge. This is you connected to earth. So when you going to connected this to earthing, what happen? All these charges flows through that. So if you touch also, you not feel any shock. Okay, that is why sometimes any new houses, if they not done any earthing to the house, that time you can operate any electrical appliances. Just you going to touch them, you will feel the electric shock. Okay, so that is why we must do earthing to our houses, right, children? You ask your parents what is the earthing, they will tell you what they'll do. So how they'll do earthing? See here, they're going to direct one underground. See, this is up to our house level. So direct one ground at the down. Okay, at level of the earth. Do some small hole or some rectangular box. They open inside that. They'll put some charcoal kind of things to absorb the charges easily, and they connect to one wire. You can observe here the wire coming from top of the building to the down. Okay, top of the building, one rod they're going to come in, bringing from top of the building to this grounding wire they're going to do. And inside your earthing wire is no, that earthing wire they're going to connect to this. Here to here, all the earthing wires from all the circuits of the house, they're going to connect this to earth wire. So what will happen? Any leakage current is coming from electricity. What happen? It will passes through this wire and it will go inside the earth. Okay, that is why your electrical appliances in your home, they are safe even though they contain metal bodies. Clear, children? Any leakage will current will come. So that is why we connected one live wire, one neutral wire, one will be for a ground wire. I think you can see this is what your socket arrangement. Live wire and neutral wire are operating. One is carrying current, one is again re-emit the current. But this is go ground current. Any leakage current will be coming because of any modes. That leakage current will be passes to the earth, and your appliances in the home will be safer, and you cannot get any electrical short because of any metal bodies and all. Okay, this metal rod, it is connected to the earth, from top of the building to earth. That is what we call lightning conductor or earth also. And lightning conductor also is connected to earthing. Why it is this means, in case of thunderstorm, okay, in case of rainy season and thunderstorm, what we'll get, that you can observe in the sky, you can observe the thunder sparks in the sky. That is what we call lightning. That lightning will hit your houses. Once they hit your houses, electrical appliances in your houses may going to blast. I think in village side, have you observed, right, children? Maybe in some news, so many TVs are blasting because of this thunderstorm. Okay, why that will be happen? Not because thunderstorm, that will be because of lightning. Heavy current will flow through electrical lines, wires will be coming into your house. Suppose electrical poles, some wires are there. So this heavy current will passes through this wire. What will happen? Your appliances will going to blast inside. To avoid that, the electrical shocks, what will coming from the thunderstorm, the rainy season, it will passes through the lightning conductor, and your home must be safer. Okay, that is what lightning conductor charges come, they will pass through ground again. Clear, children? Like that, they want to use lightning conductor or earthing. This is process what we call earthing. The symbol we're going to use to represent the earthing is like this. Okay, this small charges, so dissipating charges into the earth. That is what we can write like this. Okay, this is what earthing means in the, yeah. Next, what is the earth wire or why it is used? Okay, the wire is a thread-like thread type wire in our electric circuit. It does not carry any electricity, but one end of the earth wire is buried into the earth and other end is connected to the, okay, it is connected to the metal casing of the electrical appliances by using the 3-pin plug. You can know this 3-pin. One is connected to metal bodies. So what happened? Any by chance, if any chance, if live wire touches the metal case parts appliances, the current passes directly to the earth. Okay, that leakage current will become, that will pass through the earth. Hence, earth wire is used to prevent the people from getting shock in your houses. This wire is in a green color or insulation. You can observe this wire. Okay, children, this is about earthing wire. Okay, you can see earthing here. Like this, we can metal bodies are there, that metal bodies may get shocked. To avoid this, we're going to connect the third pin to earthing, okay, in the socket. That will be in green color. Next, sometimes you will get electric shock or some of your electrical appliances may burn because of the overloading. Okay, that is why we cannot do this overloading. So that is the meaning of overloading. You see, you can see this electrical boxes there. This plug box, all the wires are connected here. So many appliances were connected to single coil or single wire or single electrical supply box. That time you will get the, because of over voltage. So what happens? Sometimes there is a damage in the heat will produces more. When heat produces more, the virus insulation will be there, no more outside plastic that going to melt, and that will lead to destruction in the circuit or fire catches. So all things will happen because of overloading. So too many electrical appliances are used simultaneously together. So all are using simultaneously. Too many appliances are connected to the same socket. They draw the extremely large current from the circuit. They will draw, okay, extremely large. Due to this, the wire may get overload and fire may start sometime. Okay, children, that is why we cannot use so many plugs at a time. Okay, one plug we can use at a one or two at a time. That's why we can use over appliances at a time. That time we're going to observe the fire. Okay, next one. Even though we taking so many precautions also, so many times you observe the short circuit. So why this short circuit will happen? See, this is a earth wire connected to earth, and you can observe no, the live wire and the neutral wire. There, if any chances of, suppose you are inside, you can observe no, inside it is a metal actually, right, children? And outside coating, what we done, the coating is done with the plastic thing. Okay, outside coating is done with plastic, and inside you can see the metal case. Sometimes by chances, because electricity is keep on passing, more times it will going to work. Number of hour working, we just switch on the bulb and leave like that. So it is working, keep on working 24 hours also. The wire inside current will keep on moving. That time what happened? There is a liberation of the heat going to take them. Excess of heat will be liberating that plug. What will happen? It will going to burn the plastic. It going to melt whatever the plastic is coated, no, that plastic going to melt. So melt, and what will happen? It will going to melt. See, you can observe one wire, and the second wire will be circulating around like this sometimes, and the third wire is also going somewhere like this. So all the wires will be going simultaneously, because we know they have plastic coating, so that we twisted and we send. So if there is a chance of getting more heat, okay, if there is a lot of heat because of working more time, if it is work more time, what will happen? Heat liberation is more. When heat will liberate, the plastic here thing will be going to melt. When plastic will going to melt, what happened? The two metal, what is there in the one metal and another metal in the another one, they will going to what? They will going to attach. Once they'll attach, what happened? The positive and negative end going to attach. So that time you can observe the sparks of the light. Okay, that sparks of the light, what we call as a short circuit. Enormous amount of current will going to liberate here only when the wire going to melt like this, so that inside appliances will be they're not work at all. So what happened? No large amount of current will releases when the short circuit will happen. So what is short circuit? The reason is that the plastic thing what is coated, no, that will going to melt. That is only reason for short circuit. Clear, children? Short circuit means you can observe. So the live wire and neutral wire came in direct contact with each other. When? Because the plastic will going to melt that time. They causes the short circuit. This happen if insulation of the both wire get tuned. That is what is melted. Okay. Or it will maybe break sometime. It will be melted. Because of that reasons, if the plastic coating will insulation will be turn, that time you can observe the short circuit. And current flows through the wire without much resistance. So they will pass. So due to this high passage through the wire, high passage of current through the wire may get heated up and may catches the fire also sometimes. The spark you can observe, the spark may be causes fire also sometimes. So how to prevent the short circuit then? So it will be prevented by using the fuse. Over current we can avoid, right, children? Suppose if so many enemies will come to our house, that time we can destroy. Instead of that, what we do? We will put one watchman to our houses, right, to avoid the enemies to come inside. Or you put one pet dog, so that will be giving instructions to you, not allowing the enemies to inside. Like that only we are going to use or protect our house from any additional current or high current by using the fuse. So what is this fuse means? See, what is the fuse? Why it is used? A fuse is a device which is used in a circuit for to prevent the damage or appliances damage the appliances for the circuit due to overloading, or it will stop the flow under any high electrical circuit and delay. That means any without expecting, sometimes it will be high delay of the current circuits. Okay, short circuit, all the kind of things will be avoided using this fuse. So how it will be then? We need to know what is the how it is made up and how it can do this work. See, this is actually the picture of the electric fuse. So electric fuse, what it will contain? No, the live wire. This is the live wire, red color. Okay, it will be live wire, and the black color you can observe the neutral wire. It is connected to the fuse like this. So you can observe here now the small wire. The small wire, the very thin wire between the two terminals, that is what a fuse wire. And to grip under fuse grip, fuse holder, we can observe. Little not important. Only observe fuse wire. So what is the main important role of fuse wire? Fuse wire we going to use almost nichrome, very thin nichrome we going to use. So it will be operate up to 240 volts. If the current will come up to 240 volt, it will be connected to your inside appliances. From the back, we're going to connect this to your inside appliances in your home. So that means if the 240 volts more than that will come, so what will happen? This wire going to melt. Okay, once this wire going to melt, it will create a open circuit like this. The fuse wire melt and breaks the circuit, so that in your home, whatever the appliances will be safe. So how it is means, let us see children. This is the fuse. Fuse is the starting point, right? From the fuse only the live current will be come into your home. First figure you observe, no? Once again, if you want, we'll just check. First figure. You can observe here the first figure, the fuse. Here is the fuse actually. Okay, this is the fuse. From here only all the electrical appliances will work from the fuses. If the fuse allow current, then only current will come to here and it will allow. If fuse wire only breaks, suppose this is a connection, initially fuse wire is normal, current is flowing into our appliances. If there is a gap, imagine if a fuse wire going to melt, then creates a gap, so that no current will go into your appliance, so that all electrical appliances will be safe only. Unless you replace the new fuse wire between that time they won't work. Right children? This is what the fuse. Okay, you can see now. Yeah, this is the fuse, right children? So here when a current will be less than 240 volt, what will happen? The fuse will be work normally. When current will come more than 240 volt, like it is a disadvantage. Okay, disadvantages current will come, any extra current, that time it won't allow it. Instead of that, it will going to melt it and the wire going to break in between that, so create a open circuit. It will create open circuit, so appliances inside a home must be safe. So then how they will work? By again you going to ask electrician, he will come and he will put again new wire. So that time the electrical appliances will come. That means the electrician coming one day, he need to put, it will take more time, right children? Again we need to call again and again electrician to come and repair this work. Instead of that, nowadays the technology has improved that instead of replacing the fuse wire again and again, nowadays what they are using, no children, they are using MCBs, miniature circuit breakers. They are going to use the circuit breaker. I think nowadays in the electrical appliance you not see the fuse anywhere. You can apply in your homes, you can see the MCBs, miniature circuit breakers. This, what is the use of this MCBs means? See, MCBs you can observe here 240 volts actually. Okay, the word they written here, see children, approximately 240 volts. That means if it will come 240 volts, it will be trigger like this. If it is a more than 240 volts, what happened? It will be fell down. Again, you need to come and it will take it up, then it will work. Or automatically, if a current will be go low, that time it will be trigger up again, it will be working. So why this triggering will do? That means coming down and coming up. That is because of magnetic effect of electric current. What is learning no whole chapter? Magnetic effect of electric. Based on that, it will work. And also inside it, they will contain a the bimetal strip. Metallic strip. What is the use of bimetallic strip is that they will made up of two metals. Let us take iron and copper they made. When you pass at one temperature to both of this equally, so at the melting point of different metals will be different, right children? Copper will have one melting point, iron will have some other melting point. So what happened? They not having the same melting point. So one will elongate more. When you're going to heat, what happened metals? Yes, children, guess when you heat, what happened to the metals? They will go into expansion. Right, children? They're going to what? Expand. Because of this expansion, suppose which will have low melting, they will going to expand more and will take the outer part. Okay, when which will less expand, that will take the inner part. So like this, bimetallic steel going to bend. When you're going to heat, they're going to bend. Instead of the normal position like this, when you pass electricity, they're going to bend like this. So what is the advantage of bending this one is, see, initially the circuit like this is right. When there at this right, it will be connected to electrical other electrical to inside your home. Okay, like this. When high current will come, when a 240 volt will come, it is normally connected like this, and current come from this to here inside your home, it will pass it. When current will come more than 240 volt, okay, sorry, more than 240 volts of current will come. So that time what will happen? No, this bimetallic strip will going to heat up more, so it will going to bend like this. So when it will going to bend, there is a gap in the circuit will going to create. Okay, inside our home, so here because of breakage, gap is there. Because of that, this gap, the from here to here, no current will pass now. From one end to another end, current is not passing. Here it is one end to another end, current is passing because they're attached at a low temperature. When it is high temperature, there is a gap is created so that current is not flowing from one end to another end. So that is why here what a gap created, no? So that is because of miniature bimetallic strip. So this mechanism what we call as a miniature circuit breaker. This is what automatically heat and on. Again, if current will go, it will come more than less than 240, that time it will cool down. Once it will cool, no, again it will come back to natural state and the circuit will be complete again. Again, it will be attached to next coil, current will be passing. That means we cannot replace. In the last condition, fuses means we are replacing, right children? Keep on replacing fuse wire when it is going to melt. Okay, but here no need of replacing anything. It will cool, it will bend. Okay, normally it will work. Whenever it will hard, it will going to bend and circuit becomes open, so that the appliances will be safe in the home. It will automatically work like this. Okay, children, this is regarding miniature circuit breakers. Let us see if the circuit became too large, MCBs put off, switch breaking off the power supply, or this can be switched again to reuse. Switched again to reuse, we can use it, or automatically you can also do it. Okay, different types of MCBs and the fuses. Sorry, differences between fuses and MCBs is that it is a old technology and this is a new technology. It cannot be reused. We can reuse by switching on and off, or automatically it will switch on and switch off. But fuses means once it is melt, we need to replace one more fuse wire, then only it will going to work. That's why it cannot not reuse. It is not used. Now we cannot use in this in our homes. We are using now MCBs, and it will works on the principle of heating effect of electric current. When the high heat will come, the wire going to melt. That means when you pass electricity, what will happen? It will convert into heat effect. Because of that heating effect only, the wire going to melt in the fuses. But it works, the MCBs will be works on the principle of magnetic effect of electric current. Okay, that magnetic field will be produced, the magnetic field will be attached, and current will going to produce in the circuit. Okay, children, this is regarding MCBs. Okay, this is regarding the MCBs, how they will going to work, everything. And the principle is bimetallic strip or magnetic effect of electric current. You can answer this electric field. I hope this what we done in this class is it will be helpful for you. Okay, you feel this is helpful, please share to your friends. Okay, children, please like and subscribe my channel and put on the bell icon button so that if I do next video, okay, that will be maybe I'm planning to do all JE and the NEET syllabus for you. Okay, if it will be helpful for you, please press the bell icon. When I do next video, it will be helpful. You can get the notification, you can able to see that without missing. Okay, please try to share your friends, children. Okay, thanks for viewing. Thank you all, children. Have a nice day ahead.